Hi, this is the last lecture of the course Waste Management for Soil Applications, and we have talked about how to make compost, how to make vermicompost, how to make biochar, and now the only question remaining is the soil application part. How much should you apply? How much of these materials should you apply into soils? What is the criteria that you should use to apply these materials to soil? Okay, so you all seen by now these photographs where when you apply compost or when you apply vermicompost, and when you do not apply, you have one side the plants are growing very high, and on the other side the plants are not growing so well, and you say, oh, it's a great product, it will increase fertility and it will increase plant growth, but the only question remaining is, how do you know how much you want to add and why? And why? So there are two ways to respond to that question. One is if you want to increase the soil organic matter of the soil, and if you want to increase the soil organic matter, actually what we're talking about is humus, not the particulate organic matter in the soil, but humus. What is humus? Humus is a fraction of the soil solids. The soil will have a phase which is a liquid phase, the soil water, it will have the soil air, and also will have the solids. The solids, you have a mineral fraction and you will have an organic fraction. That organic fraction, the majority of it is humus, and that humus is the stabilized organic matter, the organic matter which is resistant to the degradation by the microbes. So why is this organic matter resistant to the degradation by microbes? There are several reasons for that. The first one is the easy carbon sources on that organic material were already eaten by the microbes, were already degraded by the microbes, so the remaining type of carbon in the soil is the one that is most resistant. And the other reason is this humus forms associations with the clays in the soil, with other colloids in the soil, and by doing that it stabilizes. So there's a limit to how much you can accumulate organic matter in the soil, and that limit is related to how much you can stabilize that organic matter through this clay or soil organic matter association. So humus is the fraction of the organic matter which is left after the microbes have used all the easy carbon compounds. So why do we want that humus in the soil? It's resistant to decomposition, it forms complex with the clays, and they have a lot of charges. And when they have a lot of charges, what we mean is they can hold a lot of nutrients. The charge of the soil is all present in what we call the colloids of the soil. The clays in the organic matter are the main colloids that we find. But in some clays you will find, for example, kaolinite, you will find that you have the total amount of charge is like 10 centimoles per kilogram of soil, centimoles of charge per kilogram of soil, and in other clays you have up to 100, for example, in montmorillonite, up to 100 centimoles of charge per kilogram of soil, but in organic matter you will have something between 200 and up to 800 centimoles of charge per kilogram of soil. So it can amount for the majority of the charges of the soil, and these charges are how the soil holds the nutrients for the plants. So if you have more charges, it means the nutrients, the ions of plant nutrients are being absorbed into this clay and this organic matter, and it's slowly being released for the plant as the plant takes these nutrients from the soil solution. Okay, so other benefits from the humus and soil organic matter is when you add fresh organic matter or compost, these organic matters are being decomposed in the soil, and as they are decomposed, they are releasing this mineral. So they act as a source of fertilizer, a slow fertilizer, slow release of nutrients to the soil. And at the same time, they're food for the soil microbes. So the microbes use that organic matter for energy, and therefore it busts all the the soil food web. It boosts the microbial biomass and everything that feeds on the microbial biomass also. That organic matter will also improve the soil structure, the water holding capacity, and many other physical parameters, the friability of the soils, and the whole experience on the physical side of the plant roots will be improved by how much of organic matter you have in the soil systems. And this organic matter also are strong absorbent of pollutants, so if you have a contaminated soil, that will help the soils to be less toxic to the plants and for humans. The more organic matter you have, the more stable these pollutants will be, less available these pollutants will be on the soil system. So what conditions the soil organic matter availability, or how quick this organic matter decomposes in soil? There's several factors that are intrinsic to that organic matter, which is the nature of the carbons that you have there. So if you have more lignocellulosic compounds, more stabilized organic matter, compounds that are harder for the microbes to use, these will have a slower decomposition. But if you have more sugars, proteins, carbohydrates, this will be a quicker decomposition in soils. So these are intrinsic factors for the type of organic material that you're adding, but also there are other factors that are dependent on the soil. And one of the factors that are dependent on the soil is the capacity of the soil of stabilizing that organic matter, which is related to, one, how much is the clay content of the soil, and two, what is the nature of that clay. So if you have kaolinite, for example, there is a lower capacity of the soil of stabilizing that organic matter, whereas other clays like allophonic clays in volcanic soils will be able to stabilize up to 25% of organic matter in the soil. So the limit of how much you can hold of organic matter in that soil is dependent on the amount of clays and what is the type of clays that you have on that soil. If you have a lot of high charge clays like amorphous clays, this will hold more organic matter in the soil. Whereas if you have less clays like sandy soils, or if you have soils with clays that are lower in charge, they will have a lower capacity of stabilizing that organic matter. So you might have a maximum sort of 5% in some type of clays, and a maximum of up to 25% stabilized in soils for volcanic soils, which is the other extreme. So whatever you do and you add more compost to the soil, it will increase the organic matter of the soil up to a limit, and that limit is the capacity of the soil of stabilizing that organic matter. So there is a saturation effect, a saturation level in the soil, and you will not be able to increase this. The only way you're going around increasing this is what we showed on the lecture of biochar. Biochar is a more stable source of organic matter because of the aromatic nature of the black carbon present on the biochar. So you can push the limits of the soil if you're adding this type of carbon, the charred material. The biochar will be long-lasting in soils, whereas other sources of like compost or vermicompost, you're actually looking into this more as a source of nutrients and a source of boosting the microbial biomass and the fertility, biological fertility of the soils, rather than trying to maintain and build up the amount of organic matter. But assuming that how much are you adding of organic matter in the soil? So let's make a quick calculation now to show how you calculate, how you know how much are you adding of organic matter. Make that relationship between the tons per hectare and the percentage of organic matter, okay? So let's say you have one hectare, 10,000 square meters, and let's consider the first 10 centimeters of that soil. And a given soil, we will just assume a bulk density of 1.4 for the moment. If you multiply 10,000 square meters times 0.1 meters for the depth, and if you multiply that by the density of tons per cubic meter, 1.4, you will end up having the value of 1,400 tons of soil per hectare. Now imagine if you have a soil which has 2% organic matter, it will be equivalent, multiply that 1,400 by the 2%, you will get 28 tons of organic matter per hectare. If you have 1%, it will be half of that, 14 tons per hectare. So this is the equivalence that you make between the dosage of what is the tons per hectare and how much is the percentage, yeah, in the percentage. You must use the bulk density, and you must consider also a given depth to the soil. So you calculate the volume of that soil, multiply by the bulk density, and then you get how much weight you have of that soil. Then you can easily transfer that in by the percentage for knowing how much is the tons per hectare with regards to how many percent you have. So you can do this calculation the other way around. So now imagine that you are adding 10 tons per hectare of a given compost, for example, and let's assume that the compost has 40% of organic matter, and then you are adding 4 tons of organic matter per hectare. And if you're adding 4 tons per hectare of organic matter, if you divide that by 1,400 tons, that will be equivalent of 0.286%, or let's say a third of a percent, near a third of a percent of the soil organic matter. So if you add in 10 tons per hectare of compost immediately, but the thing is, when you add this is what you're immediately adding, but this organic matter will decompose by the microbes, and the nutrients will be released into the soil, and what you will have next year will be not what you immediately added. Very little of this compost will remain for the next year. You have to be constantly adding this compost to build up and improve the capacity, the amount of organic matter in the soil, unless you are adding biochar, of course. So we are saying that if you add this organic matter will be decomposed, and the decomposition of this organic matter will lead to release of nutrients to the plants. So now let's make a calculation of what is the criteria of how much should we add about this compost to amount for the nutrients that we need for the plant. Yeah? So we think about how much. Let's focus now on the nitrogen side, because we have to choose one of the nutrients from the compost, but the nitrogen will be the most important one, most important for the plants. Let's calculate how much you should add of compost if you have a given offtake of nitrogen from this crop residue. Okay, so let's think about different residues will have different concentration of nitrogen. Normally compost will have around 2% of total nitrogen, up to 5% total nitrogen, depending on the type of compost or the type of organic waste. So you can consider between 2 and 5. If you don't know, it's a safe bet that is around 2%, yeah, around 2% nitrogen. And now let's make one simple calculation. Yeah, imagine that you have now a crop that you are trying to recommend how much you will add from compost to supply the nitrogen for that crop. In this case, in this example, will be wheat, and your expected yields of wheat will be in this calculation 1,500 kilograms per hectare. It's just for the sake of the example. And the grains will have 14% moisture. Yeah, so if you do the dry weight, you just have to divide the 1,500 by 1.14, 1 plus the moisture content, and then you will have the amount of dry weight, 1,315 kilograms of dry weight per hectare. Now you have this dry weight. This dry weight has some amount of nitrogen. So we are saying here that the percentage of nitrogen on these grains will be 2% also, okay? And the percentage of nitrogen on the compost will be 2%. So this dry weight of the grains, if you multiply that by the 2%, so how much nitrogen will you need to replenish the nitrogen that you're taking out from the crop will be the amount of dry weight multiplied by the percentage of nitrogen divided by the efficiency of that compost, which is 20%, and then you need to divide again by the percentage of the nitrogen on the compost. And in this example, if you follow the calculations here on the side, you will get that you would need to supply 6,579 kilograms of the compost to be able to give back the amount of nitrogen for that grains that you were taking out of that field. So these are a way of making a simple calculation that will replenish the nitrogen that you're taking out from the grains in the form of compost. And that is considering the percentage of nitrogen on the grains, considering the percentage of nitrogen on the compost, and is also considering the efficiency of that compost as a fertilizer, which means that if you say the efficiency is 20%, it means that from the total nitrogen that you have on the compost, you expect that 20% will end up on the plant. So this is how you make these simple calculations of recommending compost or any organic matter as a source of fertilizer. So this is just an example. You can adjust the numbers here depending on the crop and depending on the organic material that you have, and you can adapt this in any way you want. So this is all. I hope you enjoyed the lecture, and I hope you enjoyed the course, and you can always come back to this material and consult it and use it on the future if you need to make some recommendations on this matter. Thank you very much.